Let's work on applying limits to a word problem in this video. So we have a group of scientists offering to move people to a cold, desolate part of the world with a 1-year supply of necessities. So in my mind, I'm going right to Antarctica for some reason. We have this place that is normally too cold to sustain life, and we want to see if we can make life sustainable in this area. If we just give people a 1-year shot, will we develop good health care and mental health care and schools and all that? Will we be able to sustain life and have a population grow, or is the population expected to just die out or move away after time? So this is where T is measured in years from the start of the experiment, and P is given in thousands. So it says, what is the initial population? So when they move there, what is that current population starting out as? I want to keep in mind that T is measured in years from the start of the experiment, and P is given in thousands. So if we get an answer of 1, it doesn't mean only one person signed up. It means 1,000. So initially, we can just plug in what is the initial population. We're going to replace those t's with 0, so we'll have 0 plus 2.5 over 0 squared plus 1. So replacing our t's with 0, we're going to get 2.5 divided by 1, which is 2.5. And remember, this is 1,000 people. So initially there's 2.5 thousand people. If you want to make more sense of that, it is definitely possible. Just do 2.5 times 1,000 and see that there were initially 2,500 people. So 2,500 people or 2.5 thousand people trying to sustain life for a year, and we'll see what happens with the population in the long run. So this is why this is a limit word problem. If we're trying to measure the long run, we want to let time go on forever. So let t go to infinity. What happens as time goes on? Is the population going to grow without bound? Is it going to cap out? Maybe the area only fits 50,000 people, so it's going to cap out there. Or is it going to just go to 0 because people are going to have to move away? They can't live there. So we're going to take the limit as t goes to infinity of t plus 25, or 2.5 rather, over t squared plus 1. Well, if we think about this case, we have this t divided by t squared. The degree of the numerator is 1, the degree of the denominator is 2. So as t goes to infinity, this is going to be bottom heavy. You're going to be dividing something small by something huge. So what's this limit going to go to? 0. Eventually, there will be 0 people. If it was equal, I would take the ratio of leading coefficients. If it was top heavy, the degree of the numerator was higher. I would see if the answer is positive or negative infinity. In this case, with people, it only would make sense for positive infinity, but we would divide everything by the highest power of t in the denominator to calculate it normally. But this is bottom heavy. You're dividing something small by something huge. Eventually, these people are going to move away. So according to this model, this experiment is probably not going to work out in the long run. We could see what happens when we plug in like 10 years later. Did the population grow, or is it already starting to shrink? We could model how long this experiment should last, but eventually they think, everybody's going to miss their families, or it's just not an ideal situation and environment to live in, so they're going to move home. The population in the long run is going to be 0 for this one.